In this video, we're going to discover everything about a graphical tool commonly used when analyzing consumer behavior, the indifference curve. We'll find out where it originates from, its meaning, and different variations it can take in its typical form. If you want to not only learn but also understand indifference curves, join me in the next few minutes. Before we delve into its study, it's worth situating this graphical tool in the historical context in which it emerged. Within microeconomics, consumer behavior theory analyzes how individuals decide what to consume and in what quantities. From this, we economists are able to determine the individual's demand curve and, by extension, the market demand curve. Any model studying human behavior must first consider the objective driving the individual's decisions. Of the many objectives that can be pursued when consuming in economic science, achieving the highest level of utility is considered the most critical. This is the approach that English philosopher Jeremy Bentham advocated and unanimously adopted by economic doctrine when judging consumer behavior. For Jeremy Bentham, all human behavior is guided by the pursuit of pleasure, or in other words, the pursuit of utility. Therefore, when a person consumes, they aim to achieve maximum utility, and all acts of consumption should be understood in this light. From this perspective, there have been two main historical approaches in economic science that have sought to explain consumer behavior. The cardinal approach, which was based on the simple but unrealistic premise that utility could be quantified, with the utile as its unit of measurement. We discussed this matter in another video. I recommend you take a look at the following link. The approach that emerged later and has been largely accepted is the ordinal approach, because it is based on a more realistic assumption, credited, among others, to the Franco-Italian engineer and economist Vilfredo Pareto. This approach emerged in the early 20th century as an attempt to overcome the weak cardinal assumption. Nobody in their right mind, when consuming any good, like an orange for example, thinks about the utility their consumption generates, because there's no standard of measurement for utility that allows for comparing the usefulness of different consumption alternatives. The ordinal approach, as it's called, assumes something much more real, that individuals, when deciding on their consumption, rank their preferences for different goods, and this ranking is consistently carried out. To develop this new model, a suite of tools were needed to determine what the consumer's equilibrium decision would be that would assure their goal, that is, maximum utility. One of these will be the budget restriction or balance line, which we discussed in another video that you can watch in the provided link. And another one we are about to discuss are indifference curves. The English economist Francis Edgar Worth is often given credit for the concept of indifference curves, as he was the one who used them to explain equilibrium in exchange situations. However, it was Vilfredo Pareto who first employed them when studying the behavior of consumers, and in that sense in his work.
Manual of Political Economy are graphically represented as we know them today. According to Pareto, under the simplifying assumption of the existence of only two goods, the utility that an individual achieves by consuming both goods could be graphically described by what he poetically called the hill of pleasure. An engineer himself, he described the utility that can be achieved when two goods are consumed like a topographic map. To derive this hill, the origin of the indifference curves, Pareto considered two concepts widely accepted by economists at the time. Firstly, that utility increases with consumption, meaning that as an individual increases the consumption of a good, he sees its utility increase, and that a time will always come when the individual is fully satiated, and therefore successive units consumed do not alter his utility. Tightly linked to this concept is the fact that the marginal utility of any good tends to decrease as its consumption increases, meaning as the individual gets one more unit of the good, the utility it brings is less because he becomes more and more satisfied with that good, and there comes a point where the utility that the last consumed unit generates, or in other words, the marginal utility, would be 0, since the consumer feels fully satisfied. When considering these principles without going into the valuation of the tools each good produces, which would be the cardinalist view, and considering the fact that utility is additive, Pareto concludes that the relationship between two goods in terms of the utility they provide for consumers could be described as a hill, the hill of pleasure, which is the graphical foundation from which indifference curves are derived. Let's consider two goods that the consumer may have, for example, meat and fish, and graphically represent the utility of each. As we reasoned earlier, the utility of both would increase as their consumption increases until a point is reached where the individual is fully satisfied, that is, contented. If we consider that the individual consumes the two goods together, we will combine these planes to get the three-dimensional figure representing the utility that both goods provide, what Vilfredo Pareto called the hill of pleasure. From there, to derive the consumption of both goods that would provide a certain level of utility, for example, U sub 1, we would horizontally cut this hill, obtaining in this way a plane that indicates the combinations of both goods that by generating the same level of utility are indifferent to the individual. That is, we have graphically derived the indifference curve. We can estimate as many indifference curves as levels of utility are considered. For example, for a higher level of utility, U sub 2, the indifference curve would be the next, and if a level of utility still higher is considered, for example U sub 3, the curve of indifference would be next. From this analysis, we can demonstrate how infinite levels of utility could be considered, and therefore infinite indifference curves could be considered. In our analysis, for simplicity's sake, we have only considered 3 levels of utility. We can also confirm that none of them could be intersected, as each one reflects a different level of utility, and understand why the indifference curves are furthest from the original. Will reflect a higher level of utility. Once we know the origin of the undifferentiated curves, it's time to analyze some of their characteristics. To do this, let's focus our attention on just one of them. The first thing we will verify is that it has a downward trajectory which reveals something entirely logical. If we desire more than one good, for example fish, we must reduce our consumption of the other, in our example meat, in order to maintain the same level of utility. We can also verify how the indifference curves are convex, because as we go on desiring one more unit of a good, in our example fish, to maintain the same level of utility, we will be less willing to reduce our consumption of meat. In this sense, the indifference curves would be convex. In order to complete the analysis of their characteristics, we must estimate its slope as well as its meaning. For this, we will consider any point and will calculate the slope, which is called the ratio marginal rate of substitution or marginal rate of substitution between two goods. It will indicate how much I have to reduce the consumption of a good in order to obtain an additional unit, the marginal one of the other, without changing the level of utility. The marginal rate of substitution between meat and fish is, that is, how many kilograms of meat must be given up in order to get a kilogram of fish, would be indicated by the value of the slope of the tangent in that point. In continuous terms, it would be a question of estimating the rate of change derived from the amount of meat with respect to that of fish. If we want to calculate the rate substitution between two baskets, we will calculate the quotient between the variation of meat and fish when I want to switch from a basket to a basket. The other of consumption, without my usefulness varying so that both were for me indifferent. The marginal rate of substitution in this way can be interpreted as the opportunity cost I incur when I decide to change the initial basket, that is, the kilograms of meat I have to give up to get an additional kilogram of fish. Once we know how the slope of the indifference curve is calculated as well as its meaning, we are in a position to estimate the inverse opportunity cost, that is, how much fish I have to give up to get an extra kilo of meat. It would simply be a matter of calculating the inverse of the slope. In order to consolidate the theoretical knowledge acquired, we will then carry out a small practical exercise based on the information contained in the following table. If we translate this information into a graph, we could get an indifference curve like the following. If we want to estimate the marginal rate of substitution between basket A and B, we must consider the amount of meat that must be given up to get more fish. In this case, you would have to give up 14 kilos of meat to achieve 5 kilos of fish. Therefore, the marginal rate of substitution tells me that for an additional kilo of fish, I have to give up 2.8 kilos of meat. I proceed the same way if I want to calculate the marginal rate of substitution from basket B to basket C, in which case the value is minus 0.5. In other words, for an additional kilo of fish, I must give up half a kilo of meat. If we want to measure the opportunity cost of swapping fish for more meat, we need to estimate the relationship. The marginal rate of substitution of fish for meat. For instance, what would this value be when transitioning from basket C to basket B? In this case, you would have to give up 12 kilos of fish to gain 6 kilos of meat, meaning each additional kilo of meat requires giving up 2 kilos of fish. Similarly, we could calculate the marginal rate between basket B and A. In this instance, you would have to forfeit 350 grams of fish for an extra kilo of meat. From this simple exercise, we can establish that if the slope of the indifference curve or the marginal rate of substitution is known, we can understand the cost of opportunity the individual incurs when deciding whether to maintain their level of constant utility. We also verify that as we desire more of one good, we are willing to give up less of the other, since by having less of it we value it more. In other words, the opportunity cost of a good is increasing. Once we have carefully analyzed the meaning and characteristics of the typical indifference curves, which are the most frequently used in economic analysis, that is, those curvy ones with negative and convex slope, we should ponder about how the indifferent curves between two goods that do not maintain a standard relationship between them could be. Let's examine 3 cases next. Firstly, when the goods in comparison are perfectly substitutable for each other, meaning both goods fulfill the same need in the same way. A good is considered a substitute for another when it meets exactly the same need. If this substitutability is perfect, the need would be met with the same efficiency, regardless of which good is consumed. Let's suppose that the individual intends to quench his thirst and has 2 options: consuming water in 1 liter and half-liter bottles. Both products are perfect substitutes for each other, so the utility from a 1 liter bottle would be the same as that from 2 half-liter bottles. Therefore, any combination of these 2 alternatives would yield the same level of utility. This way, we have derived the indifference curve between both products. Logically, infinite indifference curves could be considered, each representing different levels of utility. Let's take, for example, these following. If we consider 2 half-liter bottles and project that point onto the indifference curve or asterisk, the resulting basket that includes a 1 liter bottle, logically, generates more utility than those baskets represented on the initial indifference curve. Thus, the indifference curve or asterisk necessarily represents a higher level of utility than the previous one. So, the further this type of indifference curves is from the origin, the higher level of utility it will reflect, and vice versa. Another case is when the products considered are perfectly complementary to each other, that is, to satisfy a need they must be consumed together. The satisfaction of a need requires the joint consumption of 2 or more goods. If this is the case, the goods are considered complementary. Obviously, the need to wear shoes is met if one shoe is used simultaneously on the right foot and another on the left foot. We can consider these 2 goods as perfect complements then, because if one is missing, no matter how many units there are of the other, the need to wear shoes isn't adequately satisfied. If we initially start from the joint consumption of 1 unit for each foot, we will achieve a level of utility that we can represent with the next point. But this level of utility would stay the same if we only had 1 unit of the shoe for the right foot, even if we have more than 1 unit of the shoe for the left foot. We can reason in the same way if we consider that there is only 1 unit of the shoe for the left foot and many others for the right foot. Therefore, the indifference curve that shows a constant level of utility throughout its entire path would be in the form of a right angle. From this analysis, it is evident that those indifference curves furthest from the origin will represent a higher level of utility, and vice versa. Lastly, when considering products with positive utility, which we typically refer to as goods, as compared to products that generate negative utility, meaning those that the individual considers to be ills. There are instances where the individual compares products that bring them satisfaction or utility, usually referred to as goods in layman's terms, to others that cause them harm or disutility. In cases like these, what would their indifference curves look like? For teaching purposes, let's say the individual in question hates flying by plane but loves to travel, and this mode of transport greatly facilitates that. If the vertical axis calculates the flight hours that the individual could make, and on the horizontal axis is the number of trips provided by this mode of transport, the negative for this individual would be traveling by a plane, while the positive would be the number of trips he could make. If we want to draw their indifference curves for these alternatives, we're going to show how they always have a positive slope, either being straight lines or curved lines. Why? To demonstrate this, let's consider any combination, for example, 10 hours of flight and 4 trips. If we want to make more trips, for example, 5 trips, which would increase our benefit, and we want to stay on the same indifference curve, that is, maintain our level of satisfaction, that greater benefit must necessarily be balanced with the sacrifice, that is, the inconvenience caused to the individual by more flight hours, for example, 14. Therefore, the new combination should necessarily be represented by a point higher. Thinking in the opposite direction, if the individual does fewer flight hours, 12, that lesser inconvenience in order to stay on the same indifference curve must be compensated with the least utility provided by the number of trips made. Now, for example, they should be 3. Once the positive or increasing slope of this type of indifference curve has been established, the next step would be to analyze the interpretation of the position of the different indifference curves on this plane. To do this, we will consider an infinite number of indifference curve maps, for example, the following ones. If we consider the inconvenience caused by having to fly 10 hours, which would count as the disadvantage, by projecting this quantity onto, for example, the U3* indifference curve, by positioning itself on the indifference curve located to the right, it would increase its utility, because the number of trips it makes is more than 7. Therefore, it can be demonstrated that when disadvantages are compared to advantages, their indifference curves would always have a positive slope, and those located further to the right would indicate a higher level of utility if the advantage is placed on that axis. On the other hand, it would be located further to the left if the advantage is reflected on the vertical axis.